Last week, we have started mechanics. There are three major sections in mechanics lesson. I have indicated them: linear motion, circular and vertical motion, and fluid. And fluid, right? But last week we have started only the linear motion section. So these things, for these three sections of mechanics lesson, these are the main sections. These are the three main sections of mechanics lesson. For these three things, you must maintain three separate books. Okay, dear? For the three main sections of the mechanics lesson, you need three separate books, right? I'll tell you how to name these books. This is book number 1. You need single rule CR book with 160 pages to 200 pages. 160 pages will be enough. But if you write in bigger size letters, if you write very big letters, because it depends on your handwriting and the size of the diagrams that you draw. So sometimes you will need a book with 200 pages. And you need another book. You need another book for units, dimensions, and measuring instruments. For this, you need single rule CR book with 120 pages. Right? So this is book number 2. Book number 1, you have to remember these things because I will not explain these things again. This is book number 2. This will be book number 3, and this will be book number 4. So you need 4 books for the first 2 lessons. The first lesson according to syllabus is units, dimensions, and measuring instruments. The second lesson according to syllabus is mechanics, right? So you have to maintain 4 separate books. Then only it is easy because there will be so many questions given for them, and theory will be there. So from the very beginning, you must maintain separate 4 books, right? And you must write clear, beautiful, neat notes. Neat. So today you must have book number 1 and book number 2. After 1 or 2 months, you can buy book number 3 and book number 4. I'll tell you. So this is a very modern technique of teaching physics, and this is the first time that I am using even in my classes, right? So you should be very careful, and you must have very good will. You must have good willpower to achieve this, right? So last week we started mechanics. The first section, the first subheading that we have written under mechanics was displacement, right? Now somebody unmute the mic and give me the definition of displacement. Displacement. Okay, I have muted all the mics. So let me just explain. Displacement is the shortest distance between any 2 points, right? Displacement is the shortest distance between any 2 points in the universe or in a given space. Okay, dear? I have forgotten to send the link for some other groups, right? What can I do then? Give me a minute. Right. I forgot it. right? Now I think things will be okay, right? So displacement is the shortest distance between any two points, right? If it is asked us to find the displacement, if it is asked us to find the displacement between any two points, for example, let's say this is point A, this is point B, we want to find the displacement from A to B. The first step is just join A and B by a straight line. Join the points A and B by a straight line. Measure the length of the AB straight line. For example, if the length of the AB straight line, let's say 2 meters, then the displacement from A to B is 2 meters and we must indicate a direction. So it is said that displacement from A to B is 2 meters into the east direction. Into the east direction. So 2 meters is said to be the magnitude of the displacement. East is said to be the direction of the displacement. We have discussed those things last week and just revise it. So what is displacement here? It is the shortest distance between any two points. A displacement has a magnitude and it has a direction. Therefore, displacement is known as a vector quantity, right? The next thing that we have learned last week is velocity. What is the other thing that we have learned here? Velocity. What is the definition of velocity, Lamai? Velocity is said to be the rate of change of displacement. Velocity is said to be the rate of change of displacement. For example, let's say there are 2 points. Let's say this is Q, let's say this is P. The displacement from P to Q, let's say 100 meters. What is the displacement from P to Q here? 100 meters. Let's say we send a toy car. We send a remote controlled toy car with a constant velocity from A to B. We send a remote controlled toy car from A to B with a constant velocity. So let's say this car takes 50 seconds to travel from P to Q. What's the time taken for this car to travel from P to Q here? 50 seconds. The time taken for this car to travel from P to Q is 50 seconds. So we can write a statement. Displacement for 50 seconds. Displacement for 50 seconds is 100 meters. Then what should be the displacement for 1 second? If the displacement for 50 seconds is 100 meters, if the displacement for 50 seconds is 100 meters, then the displacement for 1 second is 100 meters divided by 50. Unit is seconds. 100 divided by 50 is 2 meters divided by second. This division seconds comes up with the minus sign. Therefore, the unit is meter per second. Displacement for 1 second. Displacement for 1 second is said to be displacement for unit time. Displacement for 1 second is said to be displacement for a unit time. Displacement for a unit time is said to be the rate of change of displacement. The rate of change of displacement. Rate of change of displacement is the velocity. Therefore, the velocity is 2 meters per second. So what is the unit of velocity here? Meter per second. What is the unit of displacement? Meters. So last week, even though we have started mechanics lesson, we have learned units also. Right? Within next 2 hours, you will see the beauty of this method of teaching. Stay, right? So we know what the displacement is. We know the definition of velocity. The next thing that we have learned last week is acceleration. Acceleration. You have learned these things even in low levels, but these things are even in advanced level. The only difference is there is a higher depth than O level. a higher depth than no level, right? The next thing that we have learned is acceleration. Acceleration. The letter symbol A is used to represent acceleration. Acceleration is defined as the rate of change of velocity. Acceleration is defined as the rate of change of velocity. For example, let's say a vehicle travels from point C to point D. A vehicle travels from point C to point D. Starting velocity of the vehicle, let's say 2 meters per second. The ending velocity, the final velocity of the vehicle, let's say, are 7 meters per second. The time taken for this, let's say 10 seconds. So what has happened here? Within 10 seconds, velocity is increased from 2 to 7, right? So then, what is the increase? What is the increase in velocity? Look at board carefully. Do not write them because we have already written them last week. And last week lesson is completely uploaded into YouTube. So if you have not joined the class last week, just watch it and complete your note. Right. So increase in velocity for 10 seconds. Increase in velocity for 10 seconds. How do we find it? Increase in velocity for 10 seconds equal final velocity minus initial velocity. Initial velocity 2. After 10 seconds, velocity is 7. Therefore, increase in velocity for 10 seconds is 7 minus 2. That is 5 unit is meter per second. So increase in velocity for 10 seconds is 5. Therefore, what is the increase? What is the increase in velocity? What is the increase in velocity for 1 second? What is the increase in velocity for 1 second? How do you find it? Increase in velocity for 10 seconds is 5. Therefore, increase in velocity for 1 second is 10 divided by 5. The unit of 10 is meter per second. Unit of 5 is seconds. 10 divided by, sorry, that's a mistake. Increase in velocity, sorry. Increase in velocity for 10 seconds is 5. Therefore, increase in velocity for 1 second is 5 divided by 10. The unit of 5 is meter per second. Unit of 10 is seconds. 5 divided by 10 is 0.5 unit. Meter per second divided by another second. So S minus 1 with S minus 1, it will be S minus 2. So this is ms minus 2. Increase in velocity for 1 second, listen to me carefully. Increase in velocity for 1 second is said to be the change in velocity per unit time. Change in velocity per unit time. The change in velocity per unit time is defined as the rate of change of velocity. The rate of change of velocity is said to be the acceleration. So finally, we say that acceleration of the motion is 0.5. We have learned all these things last week. I'm just revising. We have already learned velocity. We have already learned acceleration. We have written the notes also. I'm just revising before I start the new section, right? Then, but what's the equation? What's the equation that you have learned in O level to find the acceleration? Somebody? What's the equation that you have learned in O levels to find the acceleration? Let me write it. The equation that you have learned in O level to find the acceleration is this. Check whether you have learned this equation in O levels. Acceleration equals increase. Acceleration equals increase in velocity. Increase in velocity divided by time taken. Increase in velocity divided by time taken. So increase in velocity means final velocity minus initial velocity. Increase in velocity means final velocity minus initial velocity. Final velocity is 7. Initial velocity is 2. Time taken is 10. Right? So what is 7 minus 7 minus 2 here? What is 7 minus 2? What is 7 minus 2? 7 minus 2 is 5 divided by 10. 5 divided by 10 is 0.5. So whether you write the statements like this, or whether you use your O-level equation directly, you get the same acceleration as 0.5. Got it here? Whether you use statements method like this or the direct equation method, you will get the same answer, right? The next thing that we have learned is, actually, as I remember, that was the final thing, equations of linear motion. What's the next thing that we have learned here? Equations of linear motion, right? To find the equations of linear motion, let me slightly change this figure. Let me take initial velocity as u meter per second. Velocity after simple t seconds as v meter per second. The acceleration, let me take the acceleration as simple a meter per square seconds, and the displacement for simple t seconds. The displacement for simple t seconds, let me take it as s meter. Right. So what are things that I have indicated here? Initial velocity is u meter per second. Velocity after simple t seconds v meter per second. Displacement for simple t seconds is s meter. Now we are going to find a relationship between these terms. Actually, we have obtained two relationships between these terms, and I have asked you to prove the other two relationships. So many of the students, they have proved and sent me the answer. They have proved the other two relationships and sent me the answer. So I'm very happy. Right. The first relationship that I'm going to prove is that I have proved this acceleration relationship. What is the acceleration relationship here? Acceleration equals increase in velocity divided by time taken. Increase in velocity means final velocity minus initial velocity divided by time taken is t. Acceleration is simple length. So let me take this simple t term to this side. So a times t equals v minus u. So a t minus u comes this side as plus u equals v. So this is our first linear motion equation. This is our first linear motion equation. If you want, we can write it as v equals u plus at. If you want, we can write this relationship as v equals u plus at. Similarly, we can obtain another three equations. Look at board. S over t equals u plus v over 2. That's the second relationship. The third relationship is s equals ut plus half at square. The fourth and the final relationship is v square equals u square plus 2a s. I think as I remember, I have discussed one or two examples for this, and I have given you even some homework. Right. Today also I'll discuss one or two questions of this our tube, especially in 600 questions tube. After that, I'll start a new theory section. And today I'll definitely start units and dimensions lesson also. Wait and see the beauty of teaching. Right. So let me show you some of the questions given in our 600 questions tube. Right. Let me show you some of the questions given in our 600 questions tube. Right. Look at board carefully. Right, I think you are able to see the screen. This is the first page of 600 questions tube. I think you are able to see it. Right. Would you please send me a message to Zoom chat if you are able to see this? Maybe video may not be clear because it's screen sharing. Right. Now let's go to the first question of the tube. Right. Look at board. Look at board. Right. So this is the tube. Now wait. So this is the first question given in 600 questions tube. Now please don't ask some silly questions. I am telling you before you ask whether linear motion is kinematics. So those are very silly questions, grade 5 questions, right? So don't ask that kind of things because now you are advanced level students. Advanced level students. So your question should be advanced, right? I'll give you a chance. I'll give you the chance. Somebody unmute the mic and read question number 1. As I remember, I did not discuss it last week. Am I right here? How I discussed it last week, Lamai? Right. Somebody unmute the mic. Now you have the permission to unmute. Somebody unmute the mic and read question number 1 loudly.
A vehicle starts to move at rest along a straight path with a constant acceleration of 2 ms minus 2. Find its velocity and displacement after 30 seconds.
Very good. Thank you very much. So there are two things. When I ask you to read the questions, you prove two things. First one is there are some students, they say they continue sending messages saying video is not clear. So if one student is able to read the question, if others are saying video is not clear, so it means there is some problem with their connections, but not my data connection. Okay, dear? Right, and it's somewhat difficult to identify real students and fake students. And the other thing is even some teachers join to the classes. Right. Especially the teachers who have not learned physics in university level. So there are some teachers, they teach according to their advanced level physics teachers note is used, and they have just photocopied the notes of other teachers and sharing it. So they don't know real physics because they have not learned physics as a subject in university. So, but those problems is normal. It happens every year. So don't worry about those things. Let's continue. Let's continue here. For the first thing in in physics and applied maths, this is common for both, right? Drawing a figure and mark the given data properly, right? So it says that there is a vehicle starts to move at rest. Somebody unmute the mic and tell me what should be the initial velocity if it is said that the vehicle starts to move at rest.
0 meter second minus 1.
Very good. The initial velocity should be 0. That's the meaning of starts at rest. Would you please draw the figure with me, dear? Let's draw the figure together and let's mark the given data. Let's mark the given data. Right. So initial velocity is, let me use the letter U for the initial velocity, equals 0 because starts at rest. Starts at rest means the initial velocity is 0. And let me mark the final velocity. Let me use the letter V for the final velocity. Is it given? No. Final velocity is not given. Final velocity is not given. And the time taken for the motion, let me use the letter T for the time taken. They have given the time taken for the motion as 30 seconds. So those are the given data. So these things are very simple. So you should know that things start with a very simple things, but ending will be very complex. If it is a normal physical class, I can give you some practical examples, but unfortunately today I'm not going to do that kind of explanations. It is the online class and I'm recording it, right? Then the displacement for 30 seconds, let me take it as S meter. I think that's not given either. That's not given either. But they have given us the acceleration. They have given us the acceleration that is 2 meter per square seconds. So everybody, please draw the figure and mark the given data. Draw the figure and mark all the given data. Start. Right, now somebody please unmute the mic and tell me the equation that we should use to find the final velocity. Lamai?
Is equal to plus 80.
Very good. We must use V equals U plus 80. Final velocity, that's what we are going to find. Initial velocity 0 plus acceleration, that is 2, time taken is 30. So actually this is not a normal vehicle. You see, what's the velocity here? What's the final velocity? Just multiply and tell me. 60, yeah. So 60
meter
this
second
is
minus 1.
impossible for to be a vehicle. So it has a huge velocity. If you convert this 60 meter per second into kilometer per hour, you will identify that this is the huge velocity, right? So as we are working with vectors, we must always indicate the moving direction of the object. We should always indicate the moving direction of the object on the top of the equation because V, U, A are vectors. So when we deal with vectors, we must indicate the directions. Right. I have sent you this PDF of this to the WhatsApp groups. Who got this answer at home, dear? Just raise your hand up if you got this answer at home. Right. The point is, maybe this question is very simple. The unit is ms minus 1. Maybe this question is very simple, but you should do homework because it should be a habit. You must have a habit of doing homework. Okay. Now another student unmute the mic and tell me the equation that we should use to find the displacement. What's the equation that we should use to find the displacement? Lamai?
SOT
S equals
is equal to U
S
plus
equals
V
UT plus half AT
divided by
squared.
2.
Very good, excellent. I'm so happy you are excellent because you are talking means you talk without a fear. You talk without a fear means you know the subject. If you know the subject, you will unmute the mic and talk to me. So you know the subject, you talk to me. Very good, happy. Right, so that is S equal UT plus half AT square. Initial velocity 0. Time taken for the motion 30. Plus half AT square, half AT square. A is 2, T is 30. We should get the square of 30. Somebody unmute the mic and tell me what is 30 times 0? 0 times 30.
0.
0, everything is 0 according to physics. You talk to your maths teacher, he will give you a different meaning. Like this half and this 2. This denominator 2 and this 2 will be cancelled out. We will have only 30 square. 30 square is 900. Therefore, the displacement of the object is 900. This clearly indicates the unit as meter. Who got this answer at home? Please raise your hand up if you have obtained this answer at home and clearly indicate the moving direction of the object on the top of the equation. Start. Shall we go to the second question there? Lamai, shall we go to the second question if the time enough? Right. So if the time is enough, if you want any more time to other things, please take a screenshot. If you want any more time to write the things, please take a screenshot because I'm going to erase everything. Right now, let's go to question number 2. Let's go to question number 2. Right? Can somebody unmute the mic and read question number 2 here.
An object starts to move at rest, obtain a velocity of 30 meters per second within 10 seconds. Find its acceleration and displacement.
Thank you. An object starts to move at rest, obtains a velocity of 30 meters per second within 10 seconds. Within 10 seconds, it has obtained a velocity of 30 meters per second. It starts to move at rest. The question asks us to find the acceleration and the displacement. Acceleration and the displacement. So we do the same thing as usual. Let's do the same thing as usual. Let's draw a figure and mark the given data. So starts to move at rest. Initial velocity 0. Final velocity they have given. So final velocity is given as 30 meters per second. Please don't be lazy. Draw the figure and mark the given data. The acceleration, it's not given. We have to find the acceleration. We have to find the displacement. Time taken is not 30. Time taken is 10 seconds. Okay, dear. So please draw the figure. Please draw the figure and mark the given data. Start. Okay, while other students are drawing the figures, somebody unmute the mic and tell me the equation that I can use to find the acceleration. What's the best equation that can be used to find the acceleration? Come on.
V equals U plus 80.
Very good. Very good. V equals U plus 80. V equals U plus 80. Right. With the final velocity, they have given us the final velocity as 30. They have given us the initial velocity as 0. Acceleration not given. Time taken is given as 10. So 30 equals 8 times 10. Multiplication 10 can be taken to the other side as division 10. So 30 divided by 10 equals acceleration. So if we divide 30 by 10, what will be the answer? Lamai?
3, sir.
It is 3. So we will get acceleration as we should write it like this. We should write A equals 3 unit is meter per square seconds. We must write the units properly, right? So marks will only be given if we have written the units. Otherwise, marks will not be given. And the other thing is, please clearly indicate the direction. Moving direction of the object, please mark on the top of the equation. Right. Is it clear here? Okay, another student unmute the mic and tell me the equation that I should use to find the displacement. What's the best equation that can be used to find the displacement?
S equal ut plus half at squared.
Very good. S equals ut plus half at square. Can you use this equation and find the displacement? Send your answer to my Zoom chat here. Start. Apply this equation, find the displacement, and send me your answer to the Zoom chat. Start. So if we apply this equation, S equals ut, u is 0, time taken given as 10 seconds, plus half acceleration we found. We found the acceleration as 3. Time is given as 10, but we must take square of the time, right? So this is just half. I'm not going to do anything to the half, but here you see, 0 into 10 is 0, plus I don't do anything to the half, 3 into square of 10 is 100, right? Square of 10 is 100. And even in the next step, I'll keep half as half. But what is 3 into 100? Somebody unmute the mic and tell me the value of 3 into 100.
300, sir.
300. What is 300 into half? 300 into half means 300 divided by 2. Because 2 is in the denominator side. So what is half into 300? Lamai?
150.
150.
150. Therefore, the displacement of the object is 150 meters. Who got this answer earlier? Lamai, who got this answer earlier? Raise your hand up there, then I can notice. Once you raise your hands up, I can note your name. Eventually, I will remember your names there. Then I can understand the students. Then I can recognize the students who work properly. Right. And if you want any more time, just tell me, write these things. But if you want any more time, it's better to take a screenshot. I'll give you about 2 minutes to write the things. I'll give you 2 more minutes to write the things. So don't blame me. I'll give you 2 more minutes to write the things. If you want, you can use average velocity equation, yes, but normally my advice is do not use average velocity equation unless you don't have any other option. If you do not have any other option, then it's okay to use average velocity equation, and all the other times try to use the first, third, and fourth equations. You'll get the same marks, right? Right, let's go to the next question. If you want any more time to write the things, please take a screenshot. I'm going to erase everything and I'm going to go to the next question. Right. Someone unmute the mic and read question number 3. Somebody unmute the mic and read question number 3. Start.
An object starts to move at rest with a constant acceleration. It travels a distance of 50 meters within 10 seconds. Find its acceleration and velocity after 10 seconds.
Thank you very much. So it's also another very simple question. So please be very happy. Please be happy, but please don't be very happy, because this is question number 3 of a tube contains 600 questions. So at least first 10 questions should be easier, right? Let's mark the given data as usual. An object starts to move at rest. Therefore, initial velocity is 0. With a constant acceleration, it travels a distance of 50 meters. Displacement is given. What is the displacement here? 50 meters within 10 seconds. So displacement 50 meters, time taken 10 seconds. Okay. Find the acceleration and velocity after 10 seconds. So it means final velocity not given. Draw the figure. Find the acceleration and final velocity. Send your answers to my Zoom chat. Okay. And at the same time, please tell me whether you are able to hear me properly. Lamai, can you hear me properly?
Yes, sir.
Okay, thank you. Right. So draw the figure, find the answers for A and B, and send your answers to the Zoom chat. What is the best equation that can be used to find the final velocity? Somebody? We can use the average velocity equation. S over T equals U plus V divided by 2. I think this equation is much easier. So let's use it. Average velocity equation. S is 50 meter. Time taken 10 seconds. U, initial velocity is 0. Final velocity is V. That's what we want to find. Divided by 2. Divided by 2. So for this case, it's easier to use the average velocity equation. If we use other equation, we have to take two simultaneous equations and we have to solve it. So that will be much difficult. So 50 divided by 10 is 5 equals, the other side 0 plus V is V divided by 2. V divided by 2 equals 5. If I take 2 to the other side, 5 times 2 equals V. So it means V equals 5 times 2 is 10 meter per second. Who got this answer? Lamai? Just raise your hand up if you got this answer, then I'll be very happy. Okay, many of you have obtained correct answer, so I'm so happy. And somebody unmute the mic and tell me the equation, the easiest equation that can be used to find the acceleration. Somebody unmute the mic and tell me the easiest equation that can be used to find the acceleration.
V equals U plus 80.
V equals U plus 80. Very good. So let's use V equals U plus 80 equation to find the acceleration. Right. Final velocity, we have found it. We have found the final velocity as 10. Initial velocity is given as 0, starts at rest here. The acceleration, we don't know. The time taken for the motion given as 10 seconds. So 10 equals 8 times 10. So 10 and 10 cancelled out. We will get A equals 1 meter per square seconds. 1 meter per square seconds. Who got this answer? Lamai, who got this answer? Okay, I'm so happy. Very good. So now you know to deal with, to work with the linear motion equations. The first 10 questions, 5-6 questions will be much easier. With the time, I'll increase the depth there. Once we have equations, the set of equations, we must use them. We must use them to solve problems. Right? We never edit an equation. For example, we do not subject A and substitute the values. That will consume a lot of time. If you try to subject simple A, if you try to subject the term simple A from B equal U plus 80 equation, and after that you are going to substitute the values, numerical values, it will consume a lot of time. So I do not recommend the method of substituting the term, subjecting a term and substitute the numerical values. I recommend the method, the only method that I have used here. Right. I want to go to the question number 4. I'll give you 2 minutes to write these things. And if you have written the things, send me a message to the Zoom chat saying done. If you have already written the things, send me a message to the Zoom chat saying done. Okay, let's go to the next question. If you want any more time to write the things, please take a screenshot. If you want any more time to write the things, please take a screenshot. I'm going to go to the next question. Right, please take a screenshot. I'm going to erase the things. Right, now we are going to go to question number 4. We are going to go to question number 4. Right? Somebody unmute the mic and read question number 4. Somebody unmute the mic and read question number 4. Start.
A car starts to move with a velocity of 5 ms minus 1 and with an acceleration of 1 over 3 ms minus 2 along a straight horizontal road for a period of 30 seconds. Find its final velocity and find the total displacement.
Thank you, dear. Thank you very much. So let's work together. Draw this figure and mark the given data. Draw the same figure. No need to indicate it as a car. Just draw a box and you imagine it's to be a car. Draw this figure and mark the given data. After that, try to solve the problem. Find the final velocity. Find the displacement. Send your answers to my Zoom chat. Do it yourself. Send me the answers. It is saying that a car starts to move with the velocity of 5 meters per second. So initial velocity is 5 meters per second. And with an acceleration of 1 over 3. Acceleration is given as 1 over 3 meter per square seconds. 1 over 3 meter per square seconds. Along a straight horizontal road with a period of 30 seconds. The time taken given as 30 seconds. They ask us to find the displacement and the final velocity. So this is the figure that we should use. So draw the figure and try to find the answers. Start there. And please quickly send your answers to the Zoom chat. If you send your answers to the Zoom chat, if your answers are correct, I'll be very happy. So that is one of the best ways to make your teacher happy. Start there. Right, somebody unmute the mic and tell me the best equation that can be used to find the final velocity. What is the best equation?
V equals U plus H.
Very good. We can use, very good dear. We can use V equals U plus 80. Final velocity, that's what we want to find. Initial velocity is given as 5. plus acceleration is given as 1 over 3. Acceleration is given as 1 over 3. Time taken for the motion is given as 30 seconds. Now you should identify that this 3 and this 30 can be cancelled out. So nothing will happen to number 5. Nothing will happen to number 5. Plus 30 divided by 3 is 10. So 10 plus 5 plus 10. 5 plus 10 is 15. So final velocity is 15 meter per second. Who got this answer? Lamai? Right. And do not forget to indicate the moving direction of the object. Right? Do not forget to indicate the moving direction of the object on the top of the equation, because we are dealing with vectors. So when we use vectors, it's a must to indicate the directions. Right. Somebody please tell me the best equation that can be used to find the displacement. What is the best equation that can be used to find displacement here?
S equals ut plus half at square.
Very good. S equal ut plus half at square. Can you do the rest and find the displacement here? Can you do the rest and find the displacement? Lamai? S is the thing that we want to find. Initial velocity u is given as 5, time taken is given as 30. So let me keep them inside brackets. That will be much clearer if I keep them inside bracket. Initial velocity 5, time taken 30. Plus half into a acceleration, that is 1 over 3. Acceleration is 1 over 3 into time taken is 30. We have to get the square. So without writing 30 square, I'll write 30 to 30. Can you understand that, Nasty? I do not write 30 square. I write 30 to 30. Because 30 square means 30 times 30. Am I right? 30 square means 30 times 30. 5 times 30, 5 times 3 is 1550. Plus, we have half here. We have half here. I don't do anything to this half. If you want, you can write half like this, isn't it? If you want, you can write half like this, 1 over 2. Half can be written as 1 over 2. Now see the beauty. See the beauty. This 30 divided by 2. 30 divided by 2. Somebody please tell me the value of 30 divided by 2.
15.
15. Very good. Then the second 30. This 30 divided by 3. What is 30 divided by 3? Lamai?
10.
10, sir.
10. Right. Now we have 150 plus what is 15 times 10 here?
150.
150, sir.
130. Very good. What is 150 plus 150?
300.
300. Very good. So the displacement is 300 meter. Who got this answer earlier? Who got this answer earlier? Anybody in the class? Very good. I'm so happy because you got the answer correctly. So it means you have understood the concept. So with the time, we can increase the depth of the questions, depth of the problems. But here is, as beginners, this is more than enough. These things are more than enough as beginners. Right. Please write these things. If you want any more time to write the things, you may take a screenshot. If you think that you want more time to write the things, the best thing is taking a screenshot so you can write them later. So even from the very beginning, you must increase the speed. You have to keep with a certain speed because there will be a huge fight with the time duration. You know that it's a 3-hour paper. Within 3-hour paper, you have to answer 4 structured essay questions and 4 essay questions, all with 8 questions. If you want to know about the syllabus and if you want to know about the structure of physics papers, you should watch a YouTube video. I have created a YouTube video and uploaded into YouTube. So I'll send you the link. Actually, as I remember, I have already sent you the link to the WhatsApp groups. But as there are some other new students, I'll resend you the link. So please watch it, then you can get a complete idea about the physics papers and the syllabus. Okay, dear? Right. Okay, shall we go to question number 5? Tamai, please give me the permission. Shall we go to question number 5?
Okay, sir.
Right, great. I'll erase the things. Can you see question number 5 now? Somebody please unmute the mic and read question number 5.
The initial velocity of a train, which is moving with a constant acceleration, is 18 km per hour. It travels a distance of 2.1 km within a minute. What is the acceleration of the train and find the final velocity?
Thank you. Excellent. A clear voice. Good. So normally when such a question is given, we convert these units. Kilometer per hour into meter per second. But here, my advice is do not convert. Do not convert because even the distance, if it is a train, it may travel along a straight line path. Therefore, distance means displacement for a train. So all the things are given in kilometers and hours. So let us use as they are. Okay, initial velocity of a train is 18 km per hour, which is moving with the constant acceleration. I don't worry about this sentence actually. We should not worry about this sentence. So what's the meaning? Just neglect the things inside the 2 commas. Neglect the things inside the 2 commas. That is English grammar. A train, the initial velocity of a train is 18 km per hour. The things inside the brackets tells us the acceleration of the train is constant. Simple grammar, right? Okay, just neglect the things inside the grammar, inside the commas, and read the sentence like the initial velocity of a train is 18 km per hour. And additional data is given within the commas, that is the train has a constant acceleration. So initial velocity is 18, unit is not meter per second, unit is kilometer per hour, kmh minus 1, kilometer per hour. Right? Acceleration, it should be not meter per second. Acceleration will not be meter per second. We don't know what the acceleration is. It should be kilometer per square hours. Final velocity, we don't know. The time taken is given as within a minute. It means 1 minute. There should be something else with the time. I'll explain it. Displacement is given as 2.1 kilometers. So my advice is do not change the unit. Use the units as they are. Draw the figure here. Draw the figure. Right. Now don't worry about the units. I'll give you some few more things at the end of the lecture. Please be patient, dear. My Tarvane, please be patient. Right. So what's the best equation to find the they have given displacement, time taken, initial velocity, final velocity is the thing that we want to find. So what's the best equation that can be used? Lamai?
S equals UT plus
S
half.
equals UT plus half AT squared.
Is equal UT plus half AT square. Yeah. Very good. That's good. So let's use the equation. Is equal UT plus half AT square. Right? So here I'm going to use everything with kilometers and hours. Right? Somebody please unmute the mic and tell me time is given as 1 minute. What should I do to convert minute into hours?
Divided by 6.
Very good. If I divide minutes value by 60, minutes will be converted into hours. Am I right? Because 60 minutes is 1 hour. So we must write this somewhere else that will be needed. So I have converted minutes into hours. I have converted minutes into hours and we will need this. Right. So let's go to this equation. S equal UT plus half AT square. S is the thing that I want. No, S is given. Yeah. S is given 2.1 kilometer. Initial velocity 18 kilometer per hour. T time taken. Somebody unmute the mic and tell me the time taken.
1 divided by 60.
1 over 60. Because if we use kilometer, time should be kept in hours. Do not forget it. Kilometers and hours. Okay, dear? Right. Do not keep kilometers and minutes. It's something like bull and a donkey. Bull and a donkey. Okay. So if you use kilometers, use hours. Right. Half into half. Half AT square. A. Do we know the acceleration, Lamai?
No, sir.
No, we don't know acceleration. Yes, we don't know the acceleration. So let me use acceleration as simple A. Acceleration as simple A. Time taken. How many hours?
1 over 60.
1 over 60. But square of 60. Square of time. So let me write it as 1 over 60. Square means another 1 over 60. Am I right here? Square of 1 over 60 means 1 over 60 into 1 over 60. You must have a very good mathematical background, then only you can understand. Science is blind without maths. Science is blind without maths. Because last week a student asked me whether I did A-level biology. So that is impossible. If I have studied biology if I follow biology stream in my advanced level, how can I teach physics? That's not possible. Because in universities you will not learn any physics. You will learn about bacteria, virus, all the diseases in the universe, plants, and there will not be any physics in universities. So without studying physics in university level, do you think it is possible to teach physics in advanced level for this much of a tough examination? So I should be mad, right? And as I know, there are no any teachers who teach us physics who have studied biology for A levels. I have not seen such a teacher, right? All the physics teachers, as I know, according to my knowledge, they have followed advanced level math stream, right? Not physics, not biology stream, right? So because they have two different destinations. So people who do it biology they are interested in saving life. They don't want to solve problems. They want to solve lives, human life. There are some kind of gods. Saving human life means some kind of godliness. So maths people, we don't care about humans. We like softwares, hardware things, electronics, materialistic things. So we like numbers. You can understand differences, right? Can you understand differences here? Two different subjects and two different visions, right? And the other thing, last week a student asked about IT. Please do not follow IT by thinking it as a simple subject, right? If you just drop chemistry and if you select IT instead of chemistry, and if you think IT is an easy subject, it means you are mad. The whole world depends on this software and information technology. It is the highest paid salary. If you want to get the highest salary and a well recognized job, you should follow software engineering. And it is a very difficult subject. It's a very difficult subject. Only very few people will understand, right? Okay, dear. Do not select IT thinking at it's a very easy subject. It's not easy. It's not easy because it's a very important and it's highly needed subject for this modern world, right? I forgot it to tell you last week. But if you want to follow civil engineering, mechanical engineering, that kind of fields, electrical, then you should select physics, chemistry as a subject. Because without some chemistry knowledge, it will be difficult to follow some of the engineering fields. But if your passion is to be a software engineer, then you should select IT, and you should understand before you select the IT. It's very tough subject, not an easy one. Right, so let's give a try to solve this problem now. Let's give a try to solve this problem, right? Now you see, here, see 18 and 16. Can you suggest me a single number that those two numbers can be divided here?
Six.
Hello?
6.
6, yeah. 18 divided by 6 is 3. 60 divided by 6 is 10. Am I right? Am I right here?
Yes.
sir.
Yeah. So plus, now again, how do we simplify these things here? Here we have simple A. What are the numbers in the denominator? There are 3 numbers in the denominator side. What are 3 numbers? We have 2, we have 160, and we have another 60. Am I right? So did I multiply them here? Did I multiply them? How I multiplied 60 into 60 and 60? Tell me just yes or no.
No.
No. because I have so many experiences of solving mathematical problems. So I didn't divide. I did not divide. I did not multiply. So that's why you need a huge mathematical background for this subject. And believe me, as I have good experience of maths, I can lead you to have a good maths knowledge. And the other thing is, I'm working with the best maths teacher in the island. I have clearly introduced that maths teacher. Please join his class, then you will definitely achieve your dreams. Right. So this is 2.1. 3 divided by 10, 0.3. And I don't do anything. I don't do anything to this simply. I don't do anything to these three numbers. What are three numbers? 2 into 60 into 60. I don't do anything to those numbers. I just keep them as they are. So next step, I'll take this 0.3 to the other side. 2.1 plus 0.3 plus 0.3 come to this side as minus 0.3 equals, what are the numbers there? Simply, Lamai, what are three numbers in the denominator? Unmute the mic and tell me.
2 into 60 into 60.
Very good. 2 into 60 into 60. Yeah, good. Right now, 2.1 minus 0.3. Just tell me. Lamai.
1.8.
1.8. Very good. Why did you take time to give that answer? Right. Then equals simply divided by half. What are three numbers in the denominator? The three numbers in the denominator.
2 into 60 into 60.
2 into 60 into 60. So finally, what should I do? Finally, I'll take those three numbers to the other side, like 2 into 60 into 60 equals simply. You see the beauty? See the beauty? We got the answer. So this is the acceleration. This is the acceleration. So how do we simplify this here? There are many methods to simplify. 60 times 60, 3,600. 3,600 times 2. Lamai?
7,200.
7,200. 7,200 multiplied by 2, multiplied by 1.8. Next people, that is 12,960. So acceleration is, finally we found the acceleration as simple A equals 12,960. Unit is kilometer per square hours. Who got this answer at home? Now you must ask me a question here. How to convert this into meter per second? Why did you ask such a question from me, dear? You think it will be something like, what's it called, disturb for me? No. Why did you ask me to convert this answer into meter per second? Oh, you are very good. Right. When I ask this question, because we have there are so many similar questions, kilometers and hours. So when I ask this kind of questions from students, they say, "So what's the answer? What's the answer here?" I ask, why did you ask me to convert this kilometer per hour into kilometers per square hour into meter per square seconds? Then what's my students' answers? I may say, I like even that kind of answers. Like, right, now we have the acceleration. How do we find what's the other thing that they have asked? I forgot the question. What's the next thing that they have asked here? Come on.
Final velocity.
Final velocity. is the best equation that can be used to find the final velocity? Lamai? Hello?
U plus
E
80.
equals U plus 80.
V equals U plus 80. Okay, I'll give you 2-3 minutes. Apply that equation. Find the final velocity in kilometer per hour. Find the final velocity in kilometer per hour and send your answer to my Zoom chat. Start. Let me erase the this figure here. I'll erase this figure. I think you have. I did something technical mistake. I erase this figure. Somewhat difficult to erase only the figure. Let me give a try. Yes. I'll erase this figure and I can't erase it. Okay, I'll change the position. Okay. Now I can erase. So while I am erasing the things, you can do your calculations and you can send me the answer for the velocity of the train, the final velocity of the train. To my Zoom chat, you must do the calculation in kilometer per hour. Okay, dear? So I have drawn the lines for you to identify the denominators correctly. Otherwise, some students may be confused. Right. Right. I want to find the final velocity. I want to find the final velocity, but wait until I draw the denominator lines for you. Okay. Now all the lines are clear. Right. Now I'll use the equation. I'll use the equation V equal U plus 80 to find the final velocity. V equals U plus 80. Final velocity. Yeah, we don't know it. Initial velocity. Somebody unmute the mic and tell me the initial velocity. It was given as I remember.
18 kilometers.
18 kilometer per hour. Very good. Thank you. Acceleration we have found. My God, it's a very huge acceleration. 12,960. A huge acceleration. Into time taken, how many hours? 1 over 60. Acceleration is 1 over 60. Acceleration is 1 over 60. Right now, what are the things that can be simply done? This 0 and this 0 can be cancelled out. Right, so zeros can be cancelled out. Nothing will happen to 18. Plus, this will be 12, 9, 6. 0 is cancelled out. Now here we have 1,296 divided by 6. Can you divide those numbers here? Help me, please. Can we divide this 1,296 by 12? 6, sorry. Possible, right?
Yes,
12
sir.
divided by, yes, ne? 12 divided by 6 is 2, 9 divided by 6 is 1, 3 remaining, 36 divided by 6 is 6, yeah, 216. So 18 plus 216, 6 plus 8, 6 plus 8 is 14, 1 remaining, 1 plus 1, 2 plus remaining 1 is 3, and is this correct? 234? Tava, is this correct?
Yes, sir.
Yeah, sir.
Yeah, so this is the final answer. Somebody unmute the mic and sorry, raise your hands up if you got this answer. If you have obtained this answer, raise your hands up. Okay, so it means almost all the students got this answer. Now, how do we convert these numbers, these values into meter per second? Lamai, what should I do to convert kilometer per hour into meter per second?
Multiplied by
Yeah, I'll give you a simple method here. Look at board. Look at board. Final velocity, we found it as 234 kilometer per hour. Kilometer per hour. So 234 kilometer per hour, h to power minus 1 will be h to power plus 1 once it is taken to the denominator side, simple maths. It will goes down, then minus sign will be plus sign. 234 kilometer. To convert kilometer into meter, what should I do here?
Multiply by 1000.
Multiply by 1000, very good. Once it is multiplied by 1000, kilometer will be meter. H plus 1, h to power plus 1 means 1 hour. 1 hour, that's the meaning. H plus 1 means h means 1, h means hour, 1 hour, right? Now somebody unmute the mic and tell me 1 hour means how many seconds? This is okay, 234 into 1000, that's okay, right? 1000, that is meter, it's okay, no problem, right? 1 hour means how much of seconds? How many seconds?
3600.
3600 seconds. Great. Right. Then look at board carefully. Then what's the unit here? This seconds comes up with the minus sign. So we will have 234 is there into. Now you see that we can cancel out these two zeros with these two zeros. Am I right here? 2 zeros of the 1000 and 2 zeros of the 3600 can be cancelled out. So you will have 10 over 36. 10 over 36 will be there. 10 over 36 will be there. And the unit will be meter. S comes up with the minus sign, S minus 1. So this is how we convert kilometer per hour into meter per second. Is it clear for all?
Yes, sir.
Right. If you divide, you see that it is possible. It is possible for us to divide both of these numbers. Look at board carefully. 234 into 10 divided by 2 is 5. 36 divided by 2 is 18. Am I right? Am I right there?
Yes.
Yes, sir.
So some students they do something like this. Whenever it is asked them to convert a kilometer per hour into meter per second, they simply multiply the kilometer per hour velocity by 5 by 80. Who has heard this earlier? if it is asked in a question for you to convert a kilometer per hour value into meter per second, then you just multiply 5 by 18 without writing the other steps. Got it? Because if you write the steps, it will consume more time. So to save the time, many of the students, they just multiply the values by 5 by 18. Please write them here. Please write and multiply and tell me the answer. Please tell me the final answer. I didn't hear you properly. Could you please ask the question again or send a message to Zoom chat because I didn't hear you properly. Can you ask the question again or did you tell me the answer? So now we have to divide this 234 by 18. What is 234 divided by 18? Somebody?
13.
30. What about others? Do you agree with him? 234 divided by 18 is 13. Yes, very good. Multiply by 5. Unit is meter per second, right? So what is 13 times 5 here? 5 times 12 is 60. 5 times 12 is 60. Therefore, 5 times 13 is 65. Am I right? 65 meter per second. Who got this answer? Lamai? Okay, very good. "65 meter per second." Is it clear now? Do you know how to convert a kilometer per hour into meter per second? Is the process clear for you?
Yes, sir.
Yes, sir.
Right. Now please tell me, how do we find, now let's say you want to find the acceleration in meter per second. So what should you do? Because some students, they have already solved this problem at home, right? Even some of you have sent me the answers to the WhatsApp. So they have converted everything into meters per second, and they have found the answers. So as a help for them, I would like to give you the method to find the answers in meters per second. How do you find the acceleration in meter per second? We know the initial velocity. So we know the final velocity. Final velocity is 65 meter per second. Wait. Quick. I would like to give you a work now. Convert. Look at board. Yeah, just now I was going for it. Initial velocity is given as 18 kilometer per hour. Can you convert this into meters per second within 10 seconds? Unmute the mic and tell me the initial velocity in meter per second. Quick.
Five meter per second.
5 meter per second.
5 meter per
Very good. How do we find it? Just multiply the given velocity by 80. Sorry, given velocity by 5 by 80. Am I right? So what should we do to convert a given kilometer per hour velocity into meter per second here? Multiply it by 5 by 18. So 18 cancelled out. Then you get the final velocity as then you get the velocity in meters per second as 5 meter per second. Is it clear for all? Lamai?
Yes,
Yes,
sir.
sir.
So we know the initial velocity, we know the final velocity in meter per second. Write them all here. Please write this one also. So whenever they have given you a question, whenever they have asked you to convert a kilometer per second into kilometer per hour velocity to meter per second, just multiply it by 5 by 18. Just multiply it by 5 by 18. Or you can write all these steps. If you love maths, write them all. But if you just want the answer, just multiply the kilometer per hour value by 5 by 18. Right, now final thing. Actually, we have already answered the question. How do we find the acceleration in meter per second? Meter per square seconds. Acceleration in meter per square seconds. Lamai? Why are you not talking? Lamai? No, not like that. Right, okay. Let me help you. Just apply, look at what, just apply V equals U plus 80. Now we know the final velocity as 65 meter per second. We know the initial velocity as 5 meter per second. We just want to find the acceleration. Time is 1 minute. 1 minute mean how many seconds, Dave? Lamai, 1 minute mean how many seconds? Hello? Yes, very good. 1 minute means 60 seconds. So just use this equation and then you will find the acceleration in per meter per square second. So here I have used this value. This 60 came from like this. This 60 means 1 minute means 60 seconds. That's why I put 60 there. Clear? Clear? So what is the acceleration in meter per square seconds? Hmm?
1 meter.
Plus 5 on this side as -5 equals A multiplied by 60. 65 minus 5 is 60 equals A into 60. 60 and 60 cancelled out. Then you will get A equals, Lamai, tell me.
One.
Yes, dear. Yes.
1 meter per
1 meter per square second.
Very good. 1 meter per square seconds. So that's the final answer. That's it. So we have learned a lot from this question. How to solve problems without doing a unit conversion and how to do the problem after converting the units. and we learn how to convert kilometer per hour into meter per second. So we have learned a lot from this question. We have it. Right, and I am not going to discuss the next 5 questions. It's your homework. Lamai, I am not stupid. So I do not discuss the next 5 questions. You should try the next 5 questions at home. Now take your book number 2. Book number 2, which is used for units, dimensions, and measuring instruments. So I have sent you 3 homework, right? I'll tell you the 3 homework again now, just at the end of the class. Take your book number 2. I'm going to start units, dimensions, and measuring instruments. Take it. Right, I'm going to list everything. If you think that you want more time to write the things, please take a screenshot here. Please take a screenshot. Right. Okay, we are back. Right. So take your new book and write the heading. Take book number 2, write the heading as units and dimensions. Measuring instruments are next week, not this week. Okay, right. I will not erase this equation. So you have written the heading as units and dimensions. Units and dimensions. So you are going to see the beauty of this method of teaching, right? Let's look at both. Right. So we have used something so called units. Listen here. I have given you 3 definitions. What are the 3 definitions I have given you in mechanics lesson there? What are the 3 definitions that I have given in mechanics lesson? You are confused. You are confused, right? What is displacement?
Shortest distance between any 2 points.
Between two
So
points.
it's a definition. It's a definition. So what is the other definition that you have learned?
Rate of change of displacement.
Rate of change of displacement.
Rate of change of displacement is velocity. Third definition.
Rate of change of
Rate of
velocity
change
is
of
acceleration.
Change of velocity is acceleration.
Rate of change of velocity is acceleration. So if somebody asks, listen, if somebody asks about 3 definitions, look at board carefully. Nobody has ever used this method in Sri Lanka advanced level physics. This is the first time that I'm going to use it. Even for me, this is the first time. So what is the definition of displacement here?
Shortest distance between any 2 points.
Definition of velocity?
Rate of change of
Rate of
displacement.
change of
Definition of acceleration?
Rate of change of velocity.
So if somebody asks you to give a common name for all these things, what is the common name?
Physical.
What is the common name that can be given for these 3 here? Okay, I add some more. You have learned some other things like this. You have learned mass. You have learned length, and we have used time. So if somebody asks you to give a common name for them, can you suggest me a common name for these things here?
Physical quantities.
They are called physical quantities. What are they called here? Physical quantities. What are they called?
Physical quantities.
Physical quantities. What is the common thing with all these things here. Displacement can be measured. Velocity can be measured and calculated. Acceleration can be measured and calculated. Mass can be measured. Length can be measured. Time can be measured. So these things are measurable. Measurable. The things which are able to measure are known as physical quantities. So you have written your heading as I have to erase. I wanted to keep this, but okay, I erase. So you have written your heading, book number 2. You have written your heading as units and dimensions. If you want, you can call dimensions. And please don't send me silly message saying whether it is okay to pronounce dimensions or dimensions. If you go to Australia, they will say Tiber. If you go to Ireland, they will say 2 runs without saying runs. So therefore, don't ask silly questions like that. Right. So the heading is units and dimensions. The subheading is physical quantities. Physical quantities. So please take your books. This is how you want to write the heading and subheading. If this is I have asked you to use a single rule CR book. So this is how you want to write a heading and a subheading. So what is the heading? Units and dimensions. What is the subheading? Physical quantities. Write them. Please write them here. Start. Right. Under the dimension, under the physical quantities subheading, write the definition. Just write the definition. If something can be measured, directly or indirectly, if something can be measured directly or indirectly, it is known as a physical quantity. If something can be measured directly or indirectly, it is known as a physical quantity. If something can be measured directly or indirectly, it is known as a physical quantity. Right, look at board. Look at board. So it means physical quantities are measurable things. Are there things which cannot be measured in this world? Lamai, are there things which are not able to be measured?
Yeah.
If I ask what is the distance from Kandy to Colombo, you can say this much of kilometers. If I ask you to measure love and care of your parents, can you measure how many kilograms? How many kilograms of love is given by your parents? Can you measure?
No, sir.
No. So there are things which are able to be measured. Those are the things that we learned in sciences. In sciences, we learn about the measurable things. There are things which are not measurable. In which subject stream that we learn about the unmeasurable things there? Can you tell me? Lamal? Give a try here. Please don't be robots, just tell me. In sciences, we learn measurable things. Where do we learn unmeasurable things which are not able to? Yes, arts. In art subjects, we learn about the things which are not measurable. Arts, literature, right? So, which are more important, measurable things or unmeasurable things here? Which are more important here? The answer is both. As humans, we cannot live without love and care. So we need both measurable and unmeasurable things, right? So let's come back to our quick lesson. Let's come back to our quick lesson. What is the equation that we use to find acceleration? What is the equation that we use to find acceleration?
Increase in velocity over time.
Very good. Increase in velocity divided by time taken. What is the equation that we use to find velocity? Lamai?
Displacement
divided by time.
over time.
Simple equation. Yeah. Yes, dear?
Displacement divided by time.
Very good. Displacement divided by time taken. Displacement divided by time taken. Yeah. So what is displacement?
Shortest
Somebody asks you
distance.
to define displacement. What's your answer? Lamai?
Shortest distance between any 2 points.
Displacement is the shortest distance. Shortest distance. Then what is the distance? When
Length.
I asked you to find the displacement between A and B points, what did we do? I have marked 2 points like this at the beginning of the class. At the beginning of the class, I think you remember. No, you will not remember because you are Sri Lankans. So at the beginning of the class, I marked 2 points like this, A and B. And I have asked you to find the displacement. What should you do to find displacement from A to B?
Drawing a line.
Join
Sorry?
AB.
Joining 2 points with a straight line.
Join the 2 points by a straight line. Very good. Join the 2 points by a straight line. Done. After that,
Measure the
Measure
length.
the AB length.
I have asked you to find the displacement from A to B. So you must join the 2 points by a straight line. After that,
Measure the AB straight line.
measure the length of the AB straight line. Length of the AB line. Length of the AB line. So length of the AB line is said to be the displacement from A to B. Am I right here? Am I right here? Join
Yes,
the
sir.
points A and B by a straight line. Measure the length of the AB straight line. For example, if the length of the AB straight line is 100 meter, the displacement is 100 meter. Right. So displacement is the length of a line. So if somebody asks what is the distance, displacement is the shortest distance. Distance is it's a length. It's a length of a path. Length of a path. AB straight line. AB straight line. AB straight line can be named as AB path. AB path. So displacement is the shortest distance. Displacement is the shortest distance, and distance is a length of a path. If somebody asks what the distance is, answer is it's a length of a path. Length of a path. If somebody asks what the length is, what's your answer here? Lamai, what is length? Hey, what is length? You have learned units and dimensions lessons in so many places with so many teachers. So I'm simply asked what the length is. Lamai? Okay, let's do something like this. We have written the heading as units and dimensions. We have written the subheading as physical quantities. Under the subheading, we have written if something is measurable, if something can be measured directly or indirectly, it's a physical quantity. Now, write down everything that I have written on the board. Write down everything that I have written on the board. And while you are writing, think a definition for displacement, think a definition for length and send me your answer to the Zoom chat. Think and send me an answer, definition for length to the Zoom chat. Start. Write down everything as I have written on the board. And at the same time, send me a definition for length to the Zoom chat. I feel so sorry about you. You have sent me so many definitions for the length. Length cannot be defined. Length cannot be defined. Length can only be measured, but cannot be defined. You can write a definition for acceleration. You can write a definition for velocity. You can write a definition for displacement, but you cannot write a definition for length. Right? The things which cannot be given a definition, the things can only be measured and which cannot be given a definition are known as, what's the name dear? Can be measurable, cannot be defined. So what's the name?
Physical quantity.
Fundamental physical quantities. Star point and write. Length is a physical quantity, but it cannot be defined by other physical quantities. Right? Google එකේ නම් මොනවද අපන්නේ? Google එකේ ඇති අතහොලෝගෙන කියලා ජීවත් වෙන්නේ මෙහෙමයි කියලා. Right? Please don't believe everything which are available in internet. Right? So put a star point and write. Length is a physical quantity and it cannot be defined. Length is a physical quantity and it cannot be defined. Such physical quantities are known as fundamental physical quantities. Fundamental physical quantities. Length is a physical quantity and it cannot be defined, by other physical quantities. Full stop. Such physical quantities are known as fundamental physical quantities. Fundamental physical quantities. You can measure them, you feel them, but you cannot define them. Same point, next star point. There are 7 such fundamental physical quantities. There are 7 such fundamental physical quantities. There are 7 such fundamental physical quantities. Can you name them? Okay, before that, please somebody unmute the mic and read the 2 star points. Somebody unmute the mic and read the 2 star points.
Length is a physical quantity and it cannot be defined. Such physical quantities are known as fundamental physical quantity. There are 7 such fundamental physical quantities.
The next star point, 7 main units. 7 units have been introduced to measure the 7 fundamental physical quantities. 7 units have been introduced to measure the 7 fundamental physical quantities. 7 units have been introduced to measure the 7 fundamental physical quantities. To measure the things we need units, right? Full stop. The units that we use at present, the units which are used at present, known as international units. The units which are used at present, known as international units, within brackets SI units. It's a French term, right? So if you just search in Google, you can find so many things about SI units. I'm not going to give that much of descriptions. because I have given you a complete description about these units in my units and dimensions tube, right? So I'll post you the tubes very soon, right? And the other thing, in the examination, they will not ask you to write about the history of units. They will never ask you to write the history of SI units, right? This is physics. This is not geography or history. So international system of units, the widely used units at present in this world known as international units. Simply it says SI units, international system of units, right? So there are 7 fundamental physical quantities. They can be defined, they can be measured, but cannot be defined. There are some physical quantities you can only measure them. You cannot write a simple definition for them. They are known as fundamental physical quantities. To measure the 7 fundamental physical quantities, scientists had introduced us 7 units. Look at board. The first fundamental unit is mass. The SI unit of mass is kilogram. The second fundamental unit is length. Length is measured by an SI unit called meter. The third fundamental physical quantity is time. Time is measured in seconds. The fourth fundamental physical quantity is thermodynamic temperature. Simply say temperature, otherwise tongue will be damaged. Temperature. Temperature is measured. What is the SI unit of temperature? Somebody unmute the mic and tell me.
Kelvin.
Kelvin. The Kelvin unit was introduced by Lord Kelvin. Lord Kelvin. So capital K should be used. Fifth one, electric current. Electric current. What is the SI unit of electric current here?
Ampere.
Ampere. Sometimes you can say electric current is the flow of charges. But is it a definition? Are you mad? You can say just when charges are flowing, current is created. Is it a definition for current? So what is current? Electrons are moving, it's a current. So why is there any definition inside it? You can find such definitions. Even you can find such definitions in some teachers' tubes. They are just something, some explanations, but it is not an exact definition, right? So you will understand those things when I teach electricity lesson. Once I teach electric current electricity lesson, you will understand the difference between a simple description and a perfect definition, right? So electric current SI unit is ampere. Sixth one, amount of substance, which is widely used in chemistry. Amount of substance, and we have our team has introduced you the best chemistry teacher in Ireland, right? So we have provided everything. So amount of substance, what's the unit here? Mole. Final one, luminous intensity. Luminous intensity. What is the SI unit here? Lamai? Candela. Simple C, simple T. The letters are simple because there was not a human so-called candela. No human called candela, so just use simple letters. Please write them all here. Please write the 7 fundamental physical quantities and their units. Start. Students send me a message, sir, how time can be considered as physical quantity? It has a definite direction and a magnitude. Can you give me the direction of time and the definition of time? You are going to win Nobel Prize. Please give me the direction of time and definition of time, please. And please give me the half of the Nobel Prize for physics, right? Yes, yeah. Please tell me. Time can be defined in one place. Where is it? So I didn't get angry, right? I'm just joking, right? So time can be defined in one place. What is that place? If you go to that place, you can define any of these things. Where is it? There is one place on the earth. If you go to that place, you can define anything. Even you can travel through the time. What is that place here? Lamai, boys, you should know it. You can define anything. You can do anything when you go to that place. Where is it?
Google.
Okay, I'll tell you the name of the country. Name of the country is America. The place?
NASA.
Sorry?
NASA.
No. If you go to NASA, no definitions. You cannot find definitions for these things if you go to NASA. Boys, you know the answer. Oh. Okay. These days, boys are very backward. They are not talking even. Oh, these boys are good. Well-connected boys and very innocent. Yeah, that is also possible, right? Have you ever heard this? Have you ever heard this? Lamai?
Yes, sir.
If you go to Hollywood, in Hollywood movies, you can define anything. I watch a film, there are some films. There are so many films. In most of the films, they have defined everything. Right, it's a joke, right? Okay, right, now we know the units. No, sure. Area 51, yeah. Okay. I have created a video about Area 51. I'll upload it. It's an interesting subject, but it is not scientific, but it's highly political. Even though it is appeared to be a scientific thing, Area 51 is a political place. I'll explain it later. I'll upload a YouTube video for it, right? Okay. So now there are some physical quantities, they can be defined. There are some physical quantities, they cannot be defined. The physical quantities which can only be measured are known as fundamental physical quantities. The physical quantities which are able to be defined are known as derived physical quantities. What are they called here? Namai? Hello?
Derived physical quantities.
So please write your next subheading, derived physical quantities. Please write your next subheading, derived physical quantities. Derived physical quantities. Derived physical quantities. Derived physical quantities. Under that, please write physical quantities which are being defined. Physical quantities which are being defined by other physical quantities. Physical quantities which are being defined by other physical quantities. By other physical quantities are known as derived physical quantities. Physical quantities which are being derived by other physical quantities are known as derived physical quantities. Can somebody read that definition? Unmute the mic and read definition. Hello.
Physical quantities which are being defined by other physical quantities are known as derived physical quantities.
Very good. Very good. Examples. Examples. Number one, velocity. What is the equation that we use to calculate velocity?
Displacement over time.
Displacement divided by time taken. So once you write an equation, for a given physical quantity, that equation itself said to be a definition. When you write an equation like this, this equation is said to be a definition, right? So velocity equal displacement is divided by time taken. So what is the unit of displacement here?
Meter.
Unit of time?
Seconds.
Seconds. So these things are very simple, dear. Within one hour, we can cover these things. It's a waste of time if you take so many examples for units and dimensions lesson, and if you do millions of questions for units and dimensions, it means you are mad. You are stupid then. So what is the SI unit of? These are very simple things, dear. What is the SI unit of velocity? What is the SI unit of velocity? Displacement, meter, divided by time taken, seconds. This S comes up with a minus sign, M is -1. So the SI unit of velocity is meter per second. Write it there, and you are going to see the next beauty within next 10 minutes. Write them there, quick. The second physical quantity, the second definition, we have learned velocity in mechanics, and we have solved problems even with velocity, right? Now we know about velocity very well because we have learned it under our mechanics lesson, right? And no need to waste time by teaching units in one day, dimensions in another day, mechanics in another day. It's a waste of time. Let's complete it here simply, right? Let's save the time, right? So what's the next thing here? Acceleration. What is the definition? What is the equation that we use to find acceleration? Lamai?
Increase in velocity over time taken.
Increase in velocity divided by time taken. Increase in velocity divided by time taken. We have learned acceleration. We have solved problems even using acceleration. We know everything about acceleration. The unit of velocity, meter per second. Unit of time, seconds. Therefore, what should be the SI unit of acceleration here? Lamai? SI unit of acceleration. Yeah, very good. Meter per second divided by second. Meter per second the denominator comes up with another minus sign. So s minus 1 into s minus 1 is s minus 2. Write it here. Right. Even in O levels, you have learned this. Therefore, I'll take one more example. According to O level science, somebody unmute the mic and tell me Newton's second law of motion here. Newton's second law of motion. Lamai, please don't give me a heart attack. Haven't you learned this equation? F equals ma in O levels. Who has learned F equals ma equation in O levels? Just raise your hand up. Yeah, so you have learned. So F is force. Force equals M mass into acceleration. Mass into acceleration. So next week you are going to learn Newton's laws of motion according to advanced level physics syllabus. Not as in O levels, but as in A level. Next week. Today we write only the units. So what should be the unit of mass? Unit of mass kilogram. Unit of acceleration ms minus 2. Right. So therefore, what should be the SI unit of force here? Lamai?
Kilogram meters per second.
Mass, kilogram, acceleration ms minus 2. Therefore, the SI unit of force is kg ms minus 2. Kg ms minus 2. Completed here. Okay. But what is the unit that you have heard in O levels for force?
Newton.
Newton. How Newton came as a unit for force? How did Newton came into action? Star point and right. Newton had done so many things. Newton had discovered so many things which were very useful for the development of physics. Newton had discovered so many things, which were very useful for the development of physics. Newton had discovered so many things, which were very useful for the development of physics. Newton had discovered so many things, which were very useful for the development of physics. Therefore, other scientists have named the SI unit of force. Therefore, the other scientists have named the SI unit of force as Newton. Therefore, the other scientists have named the SI unit of force as Newton, comma, as a respect for the scientist Newton, as a honor to the scientist Newton. Other scientists have named the SI unit of force as Newton, comma, as a honor to the scientist Newton. It's a respect. The other scientists wanted to give him a respect. That's why. So please write the relationship. One Newton equals 1 kg ms minus 2. Please draw a box around it and try to remember it. Can somebody read that star point here? Somebody unmute the mic and read that star point.
Newton had discovered so many things which were very useful for the development of physics. Therefore, other scientists have named the SI unit of force as Newton, as a honor to the scientist Newton.
Very good, excellent. Thank you very much. Who would like to listen to that definition again, that star point again? Anybody in the class? Dear, would you please read it one more time, dear? It will be a big help for other students. Please read it one more time, dear.
Okay, sir. Newton had discovered so many things which were very useful for the development of physics. Therefore, other scientists have named the SI unit of force as Newton, as a honor to the scientist Newton.
Very good. Please don't. Thank you, dear. Thank you very much. And we cannot say it is history and it is literature about physics. Talking about Newton and Einstein, it is somewhat related to history and literature. Let's talk them about later, but not now. Right. Then, how many examples should I write for units, dear? I'll write units later. I'll write some other examples later. But write your next subheading as dimensions. Dimensions. What is the dimension, dear? Sometimes you may have heard that dimension of you may have heard these things. Dimension of, don't write, dimension of length. You may have heard this as capital L, dimension of mass capital M, dimension of time capital D. But what is the dimension, dear? Simply, you may have learned. Lamai, what is a dimension? Don't write this. Don't. Oh, what again? Quickly underline. Right. What is a dimension, or what are dimensions? You are not talking, right? Okay. Please write the heading as dimensions. Under that, please write a dimension is a symbol which represents a physical quantity. A dimension is a symbol which represents a physical quantity. A dimension is the physical quantity which represent a physical quantity. If you say dimensions, they are symbols like that, right? So let me give you some examples here. So when I say something like this, you will be, if you have learned units and dimension lesson with another teacher, you will give an expression. What will be your expression there? When I say dimension is a symbol, that's my definition. When I say it, your expression, what? A symbol? Because you have done millions of questions for such a simple lesson. You say there, say this. You see this? You see this? Examples. So, look at this. Dimensions. Dimension of mass. Capital M. What is capital M, dear? Lamai, what is capital M? Capital M is a letter. Am I right? It's a letter in English alphabet. So what is a letter? A letter is a symbol. Again, what is capital M? Lamai? Otherwise, it will be late for me to stop the class, right? If you want to stop the class quickly, if you want to stop the class within next 3 minutes, you should answer me. What is capital M, dear?
The English letter.
It's a letter in English alphabet. What is a letter?
A symbol.
It's a symbol. So dimension of mass is capital M means dimension of mass is a symbol. Good, right? Symbol. Right. So similarly, what is the dimension of length? Dimension of length is capital L. If you see capital L somewhere, you should identify it is something related to length. For example, when you go to some places like hotels, you will see something like this. This kind of symbols are marked on doors. So what does it mean, dear? Only for ladies. You should not go open this door and you should not go in. This symbol represents ladies. No, I don't know the symbol for boys, right? So similarly, this symbol represents mass, this symbol represents length, and the dimension of time is capital T. So dimensions are some letters, some symbols, and they represent some physical quantities such as mass, length, and time. So if you want, you can write other dimensions also. I have included them into my tute, the note, right? So here I have written only the things which are needed for advanced level physics. So if you do not wish to learn advanced level physics, if you want to learn advanced level low sum physics in Ethiopia, so you can write the other dimensions also. If you want to sit for the A level of Sri Lanka, these are enough. Write them there, quick. Write them. I'll finish the class within next 3 minutes. But the next 3 minutes, very important. Don't leave the class, stay. Right. For these things, to say dimensions often, we use square brackets. Look at board there. So, for example, look at board. If we have written velocity, inside square brackets, the meaning of this velocity is a physical quantity. I have written that physical quantity inside square brackets. If I have written this inside square brackets, meaning is dimensions of velocity. So these are notations. This kind of notations are used in physics. So if you see a physical quantity which is written inside the square brackets, the meaning is dimensions of. If you have seen a physical quantity which is written inside the square brackets, the meaning is dimensions of velocity. So what is the equation of velocity here, Lamai? Please tell me the equation that we used to find velocity.
Meters per second.
Displacement divided by time taken. So dimensions of velocity equals dimensions of displacement divided by dimensions of time. Am I right? Velocity equal displacement divided by time. Therefore, dimensions of velocity equals dimensions of displacement divided by dimensions of time. So at the beginning of the class, I have clearly said that displacement is the length. Shortest distance, distance is the length. So please remember that displacement is the length. Therefore, what should be the dimension of displacement, Lamai?
Capital L.
Dimensions of displacement. Just look at board.
S.
Displacement is the length. So
Capital L, sir.
capital L.
Capital L.
Capital L. Let me put the inch mark here. Capital L. Time. Dimensions of time. Dimension of time.
Capital T.
Capital
Capital T. This capital T comes up to the denominator from denominator side, so that is with the minus sign. So what is the dimension of velocity here? What is the dimension of velocity?
LT minus 1.
LT minus 1. Is it clear?
Yes, sir. Yes, sir.
Right. Now you have a homework. Find the dimension of acceleration, find the dimensions of force, take a photo and send to the please send to my WhatsApp as a homework, but not now, before I start the next week class. So these are very simple things. Units and dimension is a very simple thing. Measuring instruments is much more easier than these units and dimensions. So I don't want 2 days to teach units, dimensions and mechanics. The other day I used to do papers. So you can identify my speed of teaching. So within next 2 weeks, I'll start the paper class. And paper class is a free class. So is it enough for today? Is it enough? So I think that's enough. So please write them all, then you can leave the class. Good luck. Bye.
Thank you, sir. Good night, sir.